Hey guys, I thought I'd go through this big parts and equipment donation I got from Petco Design Inc. Before we get started, I'd just like to make a quick announcement about my new website, omeganauts.com. Should be a link on the screen right now, or just go to w0labs.com and it'll redirect you. There'll be lots of details on projects that I can't include in videos for various reasons, and also projects that just aren't big enough to make a video. Anyway, a big thanks goes out to my former employer, Petco Design Inc., for donating all this stuff. There's a whole bunch of trays full of parts, boxes of like old DigiKey orders, some lab equipment, a whole bunch of things like USB and FPGA dev kits, Altium Nano board, some laser stuff, and more bins full of all sorts of hopefully useful parts. Okay, let's just start rummaging through this stuff. So we've got a Gentek laser power meter. This is the type that which has a black target that the laser hits and heats it up, and it measures the temperature difference, and also has the reader for it. Yes, plugs into the sensor, has these 12 volts, and apparently has a battery inside too. That seems to be dead right now. Okay, this seems to power up. Let's see, range switch goes from 0.03 watts up to 10 kilowatts. Wow. Doesn't seem to like 0.03 watts. How high will it go? Doesn't like being set above 100 watts either. So let's see if we can get some reading from this flashlight. I think it says a 0 control as well. Yeah, digital 0 with a rotary encoder. Let's see, just make sure there's no light. Oh, more than 1 watt. Let's try 3 watts. Yep, just about 3 watts coming out of that flashlight. Yep, that seems to work nicely. One of the problems with this type of detector is it's quite sensitive to just ambient airflow. If I just blow on this, it causes a significant reading just from my breath heating up the sensor. Obviously, all the heat from the sensor just gets dissipated into this back heatsink here. The higher power sensors are water cooled. Like anything like in the 10 kilowatt range is certainly going to be water cooled. And for those curious, this is a PS-330 V2 sensor and a TPM 300 power meter. We also have a couple of USB, Ocean Optics USB spectrometers. So a fiber coupled input, and you plug them in USB, and it's just a normal spectrometer that returns the intensity of light versus frequency. There's also, I think this is another laser power meter. Model, what is it? 1Z02090. Apparently this one has like instead of the sensor has like an integrating sphere on the input. Let's see if we can get this thing running. Okay, let's see, this has a LCD contrast pot. Let's see, all right, there we go. Yep, that seems to be working. Shine some light into it. Out of range. Oh, let's see what it does. There we go, 11 milliwatts. Let's see what this has in the menu. Offset. I guess that's 0. Yeah, 0 is the offset. So if we block it off, 0 it. Very sensitive, down to 1 nanowatt resolution. Zoom, what does that do? Range. There we go. From 30 microwatts up to 3 watts, as well as dB. Laser. What else does it have? So offset zoom, laser, no filter. Not sure how you set that. Power log tune. There, yeah. This must be a photodiode type detector where you actually have to set the wavelength. Yeah, because the gain of the photodiode changes depending on what the wavelength of the laser is. And let's turn the laser on. Let's see if that does anything. Yep, that seems pretty reasonable for this for that brightness of laser. This seems to work just fine. The rest of the box just seems to be random DigiKey parts. Looks like a whole bunch of ICs, a few very wide board-to-board connectors, and looks like just all the passives for some project. A bunch of connectors, some reels of small resistors, and some trays of bunch of BNC connectors. Tons of old dev boards here, some old, some new. What do we have? Cypress programmable IC programming kit. Looks like it's an EEPROM or a device programmer. Supports multiple EEPROM field programmable clock generators. So sort of like a PLL on a chip that you could configure. It's sort of like what you get in modern FPGAs, but just dedicated on a chip. Not sure if these are really used that much anymore with the advent of modern FPGAs, but it's a cool thing nonetheless. We have Max2 CPLD dev system. So this one fits in a PCI slot. Not too much on this board. It's got USB, probably for programming. This is an Altium NanoBoard NB1 of Altium's famous failed FPGA endeavors. I think it's one of the earlier ones because this has pretty small FPGAs. We basically have these little plug-in modules. Cyclone 1 EP1C120. There's a Spartan XC2, Spartan 2, XC2S 300. So not really that big FPGAs in this. It's like a mounting plate. And here's the actual board. Again, not that much on this. There's a little. It feels almost like a capacitive touch or one of those thin film type things. Actually, no, it looks like a resistive touch screen with a fixed backing. That's odd. So you could use it like a little drawing pad as well. Yeah, not all much. We've got a VGA output and DAC. Another small FPGA here. I wonder if this one's programmable or just acts as some sort of I/O device. Actually, this is not a resistive touchscreen. It's just a whole bunch of little surface mount buttons under a film. Where are those little modules? So these just plug in like that. Nice. Kind of old, kind of dated now. Good for a learning tool, but probably not much else. And the side box is just a whole bunch of various cables and all different mains plugs from around the world, and some it's like a JTAG cable, TMS, and such. This is a Cypress FX2 development kit. This is a USB microcontroller, basically. They're pretty overpriced. This is like $16 to buy the chip, and it's just a really old, like it's an 8051 microcontroller with a USB controller in it, and a reasonably easy to use software development stack is called the Easy USB. And quite a few products use this, but it's very expensive for what you get now. Like regular microcontrollers have built-in USB now. They also make a USB 3 version of this that's like $37 for the chip. I think it's one of the only chips available to the general user that doesn't require an NDA or such. So it's pretty popular, but again, very, very expensive for what you get. Now we got some actually more useful things. This is a Cyclone 2 DSP development platform. This is, actually has a decent, I think this has probably the biggest FPGA we've looked at so far. EP2C 70F672. And this one actually supports a stick of RAM. Actually, you can actually put a full stick of, what is this? DDR2 computer memory, so that's pretty nice. You get a lot of RAM if you have a big RAM intensive application. Also has a Cypress, I think that's an SRAM. And there's also, let's see, you got a DAC, and I think the cat wants to come in now. Let's see. Come on, get in. There we go. Yeah, I got a DAC, pluggable clocks. Looks like all the power rails are brought out the side so you can supply them from external supplies or monitor the voltages. It's probably current shunts on here as well. And it looks like, oh nice, they put probe points on every single pin of the BGA. Let's put the bypass capsule around the outside and in the center. And there's some sort of expansion that can plug into the bottom as well. Not the best cleaning on this board. They've left a lot of flux residue. Anyway, that's a pretty useful one. And it's got the usual just plugs and the adapter and, oh, what's this thing? SMA filter, DC to 48 megahertz. That must be for the DSP portion. Actually, there's probably, yeah, there's some high-speed ADCs and DACs on this, so you can probably do some sort of implement digital filters in the FPGA, and you can see you can run signals through them and such. This NIOS 2 development kit, I believe, is pretty common in education circles, or maybe no. This is a different one from the one I was thinking. Yes, an EP2C 35. So not as big as the other one, but still quite useful. It's got, this one actually has Ethernet. So they have, what do we have? Some RAM, probably DDR1, some SRAM, and a Max CPLD that's glue logic to the other stuff on the board. There's another board here. What is this? Altera Apex. This one has some slot for a laptop RAM, although they may be using that just as an I/O expansion. I'm actually not sure what this board is. That shouldn't be in this kit, actually. Anything else? It's LCD, power supply, yeah, not too much else. And what is this thing? Firefighter base. Just another FPGA dev kit. This one has lots of I/O on it. Oh, nice. Encoder has a nice feel. And 2 Ethernet ports. And some expansion stuff. What is this? Must be, yeah, DVD, some sort of educational kit. This is not an expansion board for this. This is some other fired driver. A stepper motor driver, perhaps? Yeah, probably some sort of stepper motor driver. I think there was a, yeah, there's a, maybe not stepper motor, just a brushless DC. There's a nice motor on this. Got an encoder and everything. Maxon EC Max, made in Switzerland. That's going to be expensive. Yeah, this is for some sort of motor drive development, I think. This looks like more random parts from projects. We got stepper motors. Here's some sort of XY stage of some sort. Not very smooth. Yeah, not sure what that was from. Got some, oh there we go, that's what moves. So that moves up and down. Got a optical switch there. Yeah, I wonder what this was from. Old Altera Byte Blaster parallel programmer cable. Trays of chips. Nothing even in there. Looks like it's generally very old stuff from an older project. Got any dates on these? Doesn't say. Max 17 something. Max 7432. Probably manufacturer samples. Other stuff. Ooh, this is nice. Very nice. 40 amp solid state relay. Wow, that's probably pretty expensive. That's a keeper. Let's see if I can find a date. Oh, floppy disk. Wonder if we can find any date codes on any of these. There's a stepper motor with a gear drive. Oh, 0403, so this is 2004. It's a pretty old order on these. Yeah, lots of some old PLCC. Oh, PIC 18F 4452. Yeah, you don't see PLCCs much anymore. Ooh, tons of IC rails. Various Philips chips. Most of these are filled with filler. Some optocouplers. Yeah, this stuff is kind of old to be really much use. Some old Altera FPGAs or CPLDs. What stuff is falling out? Yeah, a lot of this stuff can probably be tossed. It's not really that much use anymore. This looks like it's a bunch of sort of lighting or camera stuff. A whole bunch of these, these xenon. These are, super high pressure mercury lamp. Old lamp removed September 9th, 2009. Any information? USH 351DS, made in Japan. Yeah, these produce a large amount of ultraviolet light used for like fluorescence or for I think they're often used in chip manufacturing. That might be good for a thing for exposing for making PCBs, exposing photoresist. So this is a slightly larger one. Let's see if we have any others. Yeah, more of those ones. Slightly different style here. Have to be careful with these. I believe they produce ultraviolet to the point where you'll actually get ozone in the air because of the huge amount of shortwave ultraviolet. A few of these nice dot matrix modules. It looks like some sort of add-on board on this, like on top of the stock module. Is probably what does this say? RXTX, probably like an RS-232 converter for these LCDs. What's this one? This is, a CCD camera. Oh, nice big sensor in that. What does this say? 2/3 inch black and white monochrome camera. That's really nice. Full details and everything. Wonder if we have these connectors though. I'll have to try powering some of those up later. A whole bunch of these little keypads, because this one's been just a standard 16 key pad that's been customized for a particular application. Let's see. Get some of these lamps. What's this? Tri-band color corrector, spectrophysics. What is this? Must be a lens or filter in a protective coating. Let's see if we can get into this. Really difficult to cut this stuff. Optical filter of some sort. Let's see, can we see anything through it? Yes, we can see, if I can move this over. It does let some light through, sort of a bluish, slight bluish light. Once I get those spectrometers working later, we can actually send some light through it and see what bands this actually passes. Is this more of the same? Let's see. Yeah, that looks to be the same filter, same type of filter. I think a lot of this stuff came from a fluorescence endoscopy system or something like that. They would shine an ultraviolet or bluish light into an endoscope, and the light would come back out, go through a filter to remove the excitation light and hit a camera, so you could see what tissue would fluoresce. More camera. So it's actually just like a camera filter of some sort. Doesn't seem to. Looks like it's just a diffusion filter. What does this do? Makes it sort of diffuse, I guess. Bunch of breadboards. What does it say? Inder Singh. I think that's someone's name. Looks like there's a whole bunch of more CCD cameras. What's this? This is, oh, nice. Look at that shutter. Oh, that's so cool. Nice metal vein shutter. It doesn't go all the way closed, but that's so cool. More of these. This one's a little PCB camera. Nice, pretty big sensor on that. Bunch of Sony chips and such. More of these LCD modules. These are some really nice LCD modules. This one even looks like has a converter to just connected to a PC through a serial port. Nice for making like front panels on a device that has an embedded PC. No need for a full monitor. More of those. Soldering iron. How many is these? 3, 4. These are things you used to put over a CCD or image sensor on a printed circuit board to mount a C-mount lens onto them. A little power supply, 12 volt, 0.9 amp. More, at least 2 more of those LCDs. More of these sort of. People have gone at these button pads. There's a modified one. More of those. Those boxes. What are these? Oh, more cameras. Physics. What does it say? 3-inch color DSP camera. I wonder what that means. Has a DSP to do image processing, I guess. Another one. Yep, looks like these are all various, they must have ordered a whole bunch of different cameras for testing to do for different projects. These all sort of the same style. That's different. Oh, this one has sort of a little built-in, almost a pinhole lens. Bigger one. Actually, no, it's a remote. Oh, it's like a remote. It has a remote head, and the video processor is in this thing, and this little tiny remote camera head for when you need the tiniest camera head possible. Of course, today you can put all the electronics in this, in something a third the size of this, no problem. But these are probably from the late 90s or early 2000s. Of course, none of these are HD. These are all just standard def cameras. Look at all these. Wow. More board level cameras. Same thing. What is this? Oh, it's a reference. It's like a reference gray surface. LabSphere. What is it? Calibrated 03. Yes, this stuff is about a bit over 10 years old. Most of these cameras have probably never been used. Yep, that one's color. You can see the sort of greenish tinged infrared filter. Yeah, these are all going to be like NTSC output. I'll have to have a go at powering up some of these cameras and see what kind of images they produce. Might use them like as a kind of a waste, but use them as a security camera or something like that. I wonder if this is where they ordered them from. No, this catalog's too new. Oh, what's that little tiny... Oh, see, the image sensor at the end of a FFC cable for really, really tight applications. Let's just try out some of these cameras. This is the this bigger one here. It seems to produce actually a pretty nice color image, pretty much as good as you're going to get for any sort of for an NTSC camera, basically. This camera has a super wide-angle lens, probably 60 or 70 degrees. Pretty incredible, actually. This would be nice, make a nice security camera, or yes, you can see so much. It does have a manually adjustable focus, and you can zoom in pretty close as well. Actually, really close. This is pretty much exactly the same camera as the other one. This one just accepts a C-mount lens instead of the built-in lens. This one is zoomed in quite far due to the small sensor size. I think it's a 1/4-inch format sensor. This camera is monochrome. I think this one has a 1/2-inch size CCD. It's incredibly sensitive. I can close the iris down, and that's f/16. I got a bit of intermittent on this on the connection there, but that's the sensitivity is just incredible on this. Very sharp images you'd expect because there's no Bayer pattern to produce any artifacts. There's a whole bunch of these. I think there's about 6 of these cameras available. I wonder if I can come up with any use for them. I've got the room lights off entirely here, and we can still see everything. That's how sensitive this this monochrome CCD is. Even just a slight amount of light, you get pretty much no image noise at all. You do see a couple of hot pixels. There's that intermittent connection. Yeah, a couple of hot pixels around here, especially when it turns the gain up. Come on. In the next box, we have Xilinx platform cable USB 2. Not sure if this is any good for modern systems, but let's give it a try. And this rest of the stuff appears to be xenon lamp stuff. This is, I think it's a 300 watt Cermak style xenon short arc lamp with a built-in parabolic reflector. This would actually be really cool to build. It would kind of a crazy project. We just build it into a flashlight and have a super powerful, like 300 watt xenon flashlight. Let's see, I think that's one of the power supplies for this lamp. What does it say? Yeah, output power 300 watts, 30 kilovolt trigger, 4 to 23 amp output. So that, along with that, and the cooling fan is a complete set. There's Condor DC power supply. I think this is just, yeah, this is a general like 5 volt 8 amp, 24 volt 2.5 amps, a general purpose power supply. There's some more xenon lamp ballast. This one is 320 watts. You can see the basically the power supply on this side. This little bit here is the trigger with the high voltage, sort of almost like a little Tesla coil type sort of output pulse transformer to generate the high voltage pulse to ignite the lamp. What else? More damaged, do not use. Yeah, same thing. It looks like there's a whole bunch of where are they? There's a whole bunch of Perkin-Elmer short arc lamp bulbs. Yeah, little tiny. These are. I think these are. This is the actual core that's used inside those inside these lamps. Actually, these are 175 watt. I wonder if this is actually 175, not 300, as I had thought it was. Yeah, the entire. There's no like sort of outer like glass capsule in these bulbs. The entire bulb is pressurized at the full pressure, and then there's a super thick window on the front. Yeah, one of them is, I think that's the anode, that's the cathode. There's a whole bunch, there's probably about 10 of these that seem to be mostly used. What else? This little, I guess it's a vacuum pump of some sort. 12 volts, yeah, probably in and out, that's a pump. More bits of another pump. More bits, these are like someone's taking one of these lamps apart. These are the things that clamp onto it. Each one is the electrode, and acts as a heatsink. And we have some more 300 watt power supply, xenon power supplies. Eurostep instrument, 75 to 300 watt xenon arc lamp. And I wonder if this is built-in igniter or not. Yeah, I don't actually see the igniter bit anywhere in this, but it's probably here somewhere. Yeah, these are the high voltage, the high current wires that go out to the lamp. One thing of interest in these lamps is the hour counter here, which is basically just a little tiny solar cell. Gets activated with lamp voltage, or lamp out light output, and this generates a voltage onto this special little hour counting device, which is basically a column of mercury from one electrode to the other with a little gap in it, and the gap is filled with an electrolyte. When you put current through it, mercury is slowly electroplated from one side to the other, causing the gap to move. So as the gap moves across, you can tell how long it's been running. So it's kind of it's an ingenious and pretty hard to fake hour counter. Okay, let's give this lamp a try. It's trying to light, but it doesn't seem to want to. very bright though. Let me have to get the clamp on. Oh, and we got some smoke coming up somewhere. Where's that coming from? Okay, let's just check the current is going in the right direction. Okay, let's try this with a meter we know is not going to get blown. Measuring current. Come on, ignite. There we go. Definitely had positive current there. Didn't see what the value was though. Okay, let's just quickly test a different lamp to see if that might be the problem. Okay, that worked right away. We're only getting about half current through it, so that other lamp seems to be the problem. So let's go put a new lamp in that, and then turn the current up. Okay, let's give that another try. There's a brand new bulb installed in there now. There we go, that's better. What do we have? The rated current was about 14 amps, and actually I was reading the meter wrong earlier, so that's exactly what we're getting. Should probably put a cooling fan on that if we're going to run that for any longer. Any warmth? No, nothing so far actually. Probably run that for a few minutes without it heating up too much actually. In the manual it says to snip off the sealing pip for a dead bulb, so let's just do that. Oh yeah, quite a bit of xenon in that. Yeah, this lamp is quite far gone. You can see the aluminization or metallization on the reflector is starting to come off. That's probably why this lamp is so hard to ignite. Someone's probably either severely overheated this or it's just been run well past its rated life. Okay, I was able to fix this multimeter. I just had to adjust the offset pot inside it. I'm not sure what exactly went wrong, but it seems to be fixed now. I mean, I checked it with a known current and it is reading correctly. So now I can know it. I think I was actually reading this AVO multimeter wrong earlier. I think initially I thought it was only reading around 5 or 6 amps. That actually turns out, it seems that it is correct. So I've turned the ballast current up now to the lamp's intended 14 amps, and now it is significantly brighter than it was before. So let's give that a go. Yeah, that's significantly brighter. Now we're getting the proper 13. We can trim that up a little bit more actually. 13.4, actually it's going down. There's 14 amps. So now, get that out of there. That is quite a bit better than before. Significantly brighter. Also a lot more stable. Before you could see these sort of like waving heat images in the beam, but those are completely gone now. These little pumps are pretty cool. They're actually really quiet. They seem to produce a decent pressure and vacuum as well. These would be perfect for vacuum pickup tools or a pick and place machine or something like that. Suction, that's pressure. This box seems to be just a bunch more DigiKey parts from some random project. Lots of resistors, capacitors, a few more reels, some Molex PC drive connectors, more connectors, some boards, USB and a CPLD on these. Looks like these have all been labeled for an assembler. They have the part designators all labeled on the part, so the assembler knows where to put them. Actually, as a trick, you don't really have to do this. You can actually just specify it to DigiKey as a customer reference, and it will appear on this line. So you don't actually have to do any print that out. the DigiKey can print that on there right for you. Oh, some more cameras in this box. Looks like another CCD camera. This one's a USB interface. And this one. Well, this one, you can see the bigger area on the bottom of the chip. That means it's a CMOS sensor. It's like a similar, actually no, pretty different control board. Very different. And in this, oh, more of those serial LCD boards. How many of them? Actually, a bunch of individual LCDs. Actually, primarily just a whole bunch of yeah, just the LCD modules themselves. Oh, there's some interesting chips, sort of a different case form factor on those. Never seen anything like that before. These are mostly like laboratory stuff, like these multimeter connection test points and things like that. So I don't think there's going to be too much interesting in these. Old boards, probably I have no real use for those. Yeah, half of these are empty at least. Here's some sort of weird part. It looks like almost a pressure sensor or a transducer or something. The package it's in is for a strain gauge. I don't think that's quite obviously not what this is. So plus UB pin 2, 0 pin 6, MJGR 3 to 7. Yeah, I wonder what this is. There's no markings anywhere on it, so sort of a mystery what this is. I came across some front surface mirrors, some lenses, as well as these anti-moire filters. These are a little bit odd. They have, I don't know if you can see the pattern that's on there. You should be able to see it between the fluorescent tubes there. And this sort of blurs the image very slightly. And it's used for something like when you have when you have a fiber optic endoscope that has a bundle of coherent fibers that form an image, you'll often get a moire pattern because you get aliasing between the fibers and the pixels on the image sensor. And the only way to really correct for that was two ways: to have the image sensor pixel pitch much larger or much smaller than the fiber pitch, or put one of these anti-moire filters which blurs the image very slightly to reduce that aliasing. I don't know if you can see the difference here, but when I put it in front, it should blur the image very slightly. Most of the garbage is separated out now. I don't think I'd use any of this stuff in here, and the stuff that's left in all the trays is now supposedly the good stuff. Lots of stuff, like complete set of JST ZH connectors, and also some miscellaneous stuff that really I don't see myself using, like these RF connectors. This is the kind of stuff I don't really want to throw out because it's good stuff, but I can't really see myself using it. Yeah, and all these drawer sets now have a few drawers with stuff left in them. Again, stuff that's probably not really that useful. Anyway, that's pretty much everything of interest in this lot of stuff. I'll make a separate video on those USB spectrometers and some of the things you can do with them. Anyway, hope you enjoyed this video. Thanks for watching.